The manufacturing method is procedural and structured. Let us understand three significant manufacturing steps. Step 1. Flex PCB buildup. This is the primary phase, where the main focus is to save the base material. The primary material used for the flex circuit is polyamide. This material is expensive as compared to FR4 and needs to be used properly. For appropriate polyamide usage, you need to keep circuits close to each other as much as possible using the nesting technique. The prototype PCB manufacturing includes the following processes: looping, adding a slight amount of extra material beyond the designer's limit is acceptable. This extra material is known as a service loop that enables the servicing length and circuit assembly. Sizing conductor, it provides the greatest flexibility, thus you need to select the thinnest copper, particularly when you want to use the circuit for dynamic applications. Etching, this process is done to compensate for any isotropic losses in the manufacturing process. During this process, the line width loss is almost twice the copper foil thickness. Several factors impact the line width like different types of copper, etch mask, conductor, etc. Routing of the conductors can be done easily. Simply get on the perpendicular position to the bend and fold. This will improve folding and bending by reducing stress. Ground planes, create ground areas cross-hatched if the electrical allocation is adequate. This aids in improving the flexibility of the circuit by reducing the weight of the circuit board. Step 2. Flexible printed circuit board, PCB, fabrication process. Now, let us focus on the boards. It starts with conductor spacing and width. Polymer thin films require a standard conductor width, i.e., 375 micrometers. Simultaneously, the nominal polymer thick films and silver-based polymer films carry the desired percentage of circuit current. The diameters of holes in flexible PCBs can vary depending on the design and application. Size of the holes. The manufacturer can create small holes and is also capable of a flexible PCB layout to be well inclined. With advanced technology, you can make holes as small as possible. Filleting is a technique where you can multiply the area of the pad and divide the stress. All the pads and land termination points on your flexible circuits need filleting. Plated through holes is appropriate to create a reliable solder joint. Button plating, here, you can create a substitute plated through hole. These days, manufacturers use copper to prepare vias and through holes. Step 3. Concentrate on physical constraints. In this process, manufacturers deal with cover layers and cover coating problems. We bring to you a few common cover layers used in the process. Adhesive-backed films. It is appropriate for dynamic flex circuit apps as it consists of raw materials. Adhesive-backed films are used mostly for overcoating custom PCB. The advantages of flexible printed circuit boards. Electronic devices have taken upon a prominent part of our everyday lives. The extensive range of devices from cell phones to servers, regardless of their sizes and uses, are now being designed to be flexible, lightweight, and efficient. While they all come in diverse shapes, sizes, and functionalities, there is one thing in common: they include flexible printed circuits boards. Benefits of using FlexPub's flexibility. The most prominent benefit: the elastic nature of the Flex PCB allows placement around edges and folds. The flexible nature of the Flex circuit boards are used in electronic devices that require 3-axis connections. Very little or no wiring is required that eliminates wire connection failure and increases the reliability of the device. Space and weight savings. Flex PCBs save up to 60% of the weight and space compared to rigid PCB or wire harness applications. Bending cycles. Flex PCB use in 3D designs eliminates connectors, while the number of bending cycles can be as many as 200,000, with standard material, anti-vibration benefits. Added flexibility and lighter weights allow the flex circuits to absorb and reduce the impact of the vibration to itself, as well as any solder joints in connections used in harsh environment. Flex circuits can be built with materials that are suitable to use in harsh operating environments, materials that have the following properties: waterproof, moisture-proof, shock-proof, high-temperature oil, corrosion-resistant. Consistent thin inner layers. Heavy copper layers. EV copper layers can be used for high-power uses with thin copper layers for flexibility. There are a number of advantages using flex PCB. Flexible circuit boards are specifically designed to save room and improve flexibility in meeting smaller and high-density mount designs. They also reduce the items in the overall assembly process and enhance reliability of the PCB. The other advantages of flex PCB are increased heat dissipation capabilities, improvement of airflow inside box. Required package sizes are reduced, package weights are reduced. Assembly time reduced, reduced assembly costs. 25 point-to-point wire use circuits are flexible. Assembly errors are reduced, system reliability is increased. Fewer inductance cabling required, improved product appearance.